This is question 15 of GATE 2012 Chemical Engineering paper. The question is, a solid sphere with an initial temperature Ti is immersed in a large thermal reservoir of temperature T0. The sphere reaches a steady state temperature. The sphere reaches a steady temperature after a certain time T1. If the radius of the sphere is doubled, the time required to reach the steady state is dash. So from the given four options, we have to find the time required to reach the steady state if the radius of the sphere is doubled. So this question is related to lumped heat capacity analysis. So let's consider this as a large thermal reservoir, and it has a fluid, and in this we are having a solid sphere whose initial temperature is Ti, and the is immersed in a large thermal reservoir of temperature T0. The temperature of this thermal reservoir is T0. After a steady state, the sphere reaches a steady state temperature after a certain time of T1. So steady state temperature is T1, and in this case radius is equal to R. So let's consider this as case 1. In case 2, this is steady state time. Steady state time in this case is T1. In this case, let's consider steady state time as T2, and the radius will become 2R. In each of these cases, this initial temperature Ti is same. The temperature of the large thermal reservoir T0 will be same, and if the steady state temperature is Ts, that will be also same in both the cases. So that is, we can write T minus T0, which is the temperature of reservoir, minus T, the initial temperature of the sphere, the initial, minus T0. This we can write it as exponential of minus of HAT upon rho Vc. Now for case 1, this temperature, it takes time T1 to reach the steady state temperature of Ts. So that we can write it as Ts minus T0, T init minus T0 is equal to exponential of minus of H A T upon rho Vc, where T is T1. So this is for case 1. Similarly for case 2, we will be having Ts minus T0 upon T initial minus T0 is equal to exponential of minus of H A T1 upon rho Vc. So now let's just consider for this case 1, the area will be A1, volume will be V1, and H, rho and C will remain constant. So for this also A2 and V2. So this left hand side, both the terms are same, so we will equate both this equation and we can get HA1 T1 upon rho V1C is equal to HA2 T2 upon rho V2C. So H rho V will get cancelled out, and we will be having V2 is equal to A1 V2 upon A2 V1 into T1. Now the surface area of the sphere will be 4 pi r square. Similarly, the volume will be 4 by 3 pi r cube. Similarly, we will write it for the denominator. Into T1. So we can cancel all these terms. So this term will become T2 is equal to This will also get cancelled. T2 is equal to R2 upon R1 into T1. And we have been given in the second case the radius is doubled. That is T2 will become twice of T1. So our final answer is if the radius of the sphere is doubled, then the time taken to reach the steady state will be also doubled. So from the given option, we will select option C as the correct answer.